something to note immediately, even though we have a system of equations, instead of asking for the point of intersection of these two lines, they're asking for how many solutions does this system have. And we could see that by looking at the answer options, that they aren't just ordered pairs, but rather they're saying how many solutions, which is why even though we don't look at the answer options right away, we know it can be useful to look at the answer format. And that gives us a quick way of knowing, okay, we just got to figure out how many solutions. And to do that, let's go to page 33, more specifically side 2. And notice here we talk about the different scenarios, and there's only 3 of them. Now, if you have 2 lines that have different slopes, really the key thing is that you could have potentially one solution in this case. In this case, because the lines are parallel and never touching, you have 0 solutions because the solution is a point of intersection. And here, where it looks like it's just one line, it's really 2 equations that are the exact same line, and as a result, they have infinitely many points in common. Now, you can already see that they're not the exact same line, because how can they have the same x coefficient but different y's? So it's not going to be infinitely many solutions, and if we want, we can eliminate it. But the point is, let's go ahead and graph this in Desmos, remove any other equations we have by clicking the gear icon and delete all, and then we'll type this in. So 6x plus 2y is equal to 3, and then we'll type in the second equation. And there you go. The fact that they are intersecting at all means that it's that one solution. If they were the exact same line on top of each other, of course, it'd be infinitely many. But that makes it very clear that we get exactly one solution, so option B.